Hello everybody, welcome. I'm Brad Clark, and Raf is going to take over here very quickly, so we have all the focus on him. But anyway, thanks for taking the time to come by and check out the event. What else? So let's get going.
Hey guys, so I am Raf Anzovin, and I am talking about the Setup Machine 2 and the rig that it creates, and a few sort of interesting tips and tricks that came from developing that rig, and you know what sort of state it was in after being developed in around 2004, which was a while ago, and there are better ways to do some of those things now, and I'm going to talk a little bit about that too. So first of all, I wanted to mention I have a bunch of topics to talk about and a bunch of stuff to show. I don't mind if you guys ask questions while I'm going on about this. Obviously, if I'm in the middle of talking about something, I might not take the question right then, but feel free to ask me stuff, and I'll try to work that in as best I can. Um, yeah, we should be able to get started. TSM2 was designed as an auto rig system for pretty much with two main things in mind. One was that the rig it created had to be very easy for animators to use, and there had to be certain very specific ways in which an animator could reshape the character. That at least at the time, you know, while they were certainly not unheard of, weren't as common in rigs as they are today. And also that it had to be modular. That is, it had to be pretty easy to create a fairly wide variety of character types and body designs. Um, and for anyone of you looking at this who've used the setup machine, you kind of have an idea of how that works. You bring in widgets, you hook them up together, and it builds the rig from there. Um, so it was designed with those two things in mind, specifically the modularity and the ease of use by an animator. What it wasn't designed for particularly was was to be easily modified. And the method that I used to develop TSM2 is kind of a quick and dirty method, actually. I think it's kind of interesting. But it's not necessarily how I would recommend that someone design an auto rig system from scratch, and it's certainly not how I would do it if I had to do it all over again today. Which I actually do have it to do all over again today, because we are doing TSM3, and we're going to be doing a new version that's a ground-up rewrite that does a bunch of things that I did wrong for TSM2 right. So, first of all, I wanted to talk about that and talk about basically, you know, what's the structure of this rig, and why it was structured that way, and there might be some things that would be, you know, instructive about that. So if I were to you know, go down and, you know, sort of look at the hierarchy for instance an arm rig. I mean, there's all kinds of stuff going on, obviously, but the part that's relevant right now actually is that there's two specific separations, and this is sort of maintained in all of the different widgets of the different systems. Um, that is in every system, you know, an arm or a leg or a spine, what have you, which is that you have joints over here separated from rig, and the rig contains all the controllers and all the controls, the nerve curves that the animators are actually going to grab onto, and it also contains all of the working hierarchy. So you know, there's all kinds of stuff going on in there. To make the rig work, there's extra joints and IK handles that are doing various things inside the rig that you would not, you know, you don't necessarily want to see in the hierarchy that you're using for joints. And then you have joints, which are exactly what they sound like. They are the joints that you will see if one were to if we go over here and sort of show joints, you'd see, you know, the joint structure, and that needed to be kept separate, because anytime you're binding to a structure of joints, but those joints are buried within a separate rig system, you can run into a lot of trouble. Um, in that your hierarchy contains all kinds of stuff and you don't really know what it is. And the other thing that the joints contain are influence objects, because TSM2 will actually bind to a set of influence objects that are parented to those joints, which gives you an extra layer of control because you can animate those on top of whatever it was you were doing. But regardless, it was important that there was a certain visible hierarchy of joints that you as the user can then do whatever you want with, and you can bind to it without the influence objects. You can parent things to it. You can drive driven keys off of the rotation of those joints. You can pretty much do whatever you want. The one area in which TSM2 though doesn't keep the purity of the hierarchy in the way that it probably should, and if I had this to do over again, I would, is that all of that section there, the rig section and the joints section, are and I'll get into what this is first for a moment. They're all buried inside the joints section of the hierarchy that they are attached to. And that means that it's not, while it's a clean, while the division, it's a useful division, it's not completely clean. You still have a hierarchy that contains both rig and joint elements. And when I redo this rig for TSM3, I'm going to make sure that they're completely separate. Regardless, though, the reason why it was set up that way is because as far as figuring out how the limbs were going to relate to each other, it was actually a lot easier to do it that way because of this thing here, the scaling compensate. Now, you may notice that, if I were to scale the spine, which is something that you're supposed to be able to do in a TSM2 rig, you're supposed to be able to do whatever you want about scaling and manipulating any of these controls. But if I were to scale the spine up, the arms do not they don't scale at all. Actually, they have no relationship to the spine as far as scaling is concerned, but they do scale their positions, as it were. They are being pushed out to an appropriate position, as if the spine were scaling, which it is. And if that were not the case, you would either see the arms remain precisely at their position because they wouldn't inherit scale at all, or you'd see the arms get pushed, get fully scaled out. They'd be sort of pushed out, and you'd see the whole upper body scale, which would elongate the arms and do all kinds of things that you don't necessarily want to do. And one of the things that I wanted to think a lot about when I was designing the rig was to make sure that all of the systems were completely separated in their rotation and scale, so that they don't have to be separated in rotation, but most of the time they probably would be, so that when an animator is going to go and animate this, they can go ahead and scale or reshape any part of the rig without worrying about how they're affecting the hierarchy. And that's something that I think is kind of important when you're designing rigs for animators, especially if you're designing a rig that is supposed to allow for both a more realistic and a more cartoony sort of approach, is that you always want to make sure that animators can isolate things as much as possible. And this TSM2 doesn't even take that as far as it can go by any means, but certainly it went that was one of the goals that I had at the time, and pushed that further than it had been in our previous rigs. Although, like I said, there were certainly plenty of people out there in the industry doing similar sorts of things. Part of that was inspired by the SIGGRAPH presentation that had come out around that time for Chicken Little, where Disney was demoing their what they called broken rigs. And I think that affected a lot of people's thinking about how you want to present a rig to an animator, that keeping things isolated and keeping things something where manipulating one part of the body does not necessarily disturb the rest of your pose was sort of actually an important thing that traditional hierarchies, the way to think about hierarchies in a traditional way, tended to make more difficult. And in fact, if I were to switch every single control in a TSM2 rig to IK, you'd have something pretty close to a broken rig. I can even do it for the head. In fact, this is something that people don't really use very much because most of the time you kind of want to have the head attached to the body, but I do happen to have the ability to switch to the head and quite literally reposition it any way I want. And let me just turn off joint selection there. There we go. And essentially leave it in place while I do whatever I want with the body. So that's broken rigging right there. But not something people do a whole lot, as opposed to, say, using IK hands, which obviously people do all the time. So the what that in order to create that, I mean, it's actually really a pretty simple sort of trick, but I wanted to generalize that as being something that I did for all systems, so that they could all be separate. And what this scaling compensate does, I should mention here that I'm looking here at the hypershade. So if I just take a look at the input connections for this scaling compensate, you can see that spine joint 7 is being pumped through this multiply divide node. Now another thing that I'm doing with why I'm using a multiply divide node here, as opposed to any of the other ways one might do this, like an expression, or you can even do this with a driven key, I guess, if you wanted to, is that basically, it's a fairly common technique, and it's a good idea to try to minimize the amount of expressions that you're using in your rig, and use math nodes and driven keys, and I mean there's lots of things that are a good idea to use. As much as you can, because they will evaluate faster, although they do make your graph kind of complex looking. And in this case, and you'll see that when I show you some of the other systems inside TSM2, they're full of math nodes, primarily multiply divides and adds, add subtracts, just doing all of the math necessary to make the rig go. And all this is doing, and it's actually completely not obvious what it's doing right now because I haven't actually scaled anything. But if I was to, scale this, you would see that what it's doing is it's taking, I believe that's actually being used to divide. Yes, indeed it is. And what it's doing is it's taking 1 and dividing it by all these input numbers, which gives you out the scale that will undo the scaling of something up the chain in the hierarchy, the inverse of that scale, as it were. And that's sort of what goes between every everything in the rig, so that when I go about scaling this, it won't actually affect the arms improperly. And there were a bunch of things like that. Whoops. Yeah, I shouldn't probably maybe put my scale down to 0. I should really go to 1. And then it messed up the thing with the eyes. That doesn't really matter. That I tried to come up with a bunch of general rules like that so that I could plug in any piece of rigging. So I've got a rigged arm or a rigged leg or what have you, and they all have a bunch of general rules for how they fit together, and what they do, and how they're linked, and how the behavior of one will affect the behavior of the other. And I mean that's a pretty simple example, but I was trying to put this together in a sort of pretty quick way. Now here's the hack that sort of actually makes it all work, and let me just make a new scene here actually for a second. And I'm just going to go ahead and build, just build a part. It doesn't even matter what part I build. You'll get the idea. I'm just going to build a spine. It brings in the spine. Now, anyone who's used TSM2 is familiar with the concept of a widget, which is to say, widgets are these things that you place inside the character in order to make your rig go. And it will build the rig from the widgets. What may not be apparent, unless you've gone to look, is that inside the widget, you actually contain a fair amount of the rigging that will actually be in the final version, and it's all being driven directly by direct connections coming in from the widget layer. So I've got several layers here. So you remember the rig and the joints layer? Well, those are already present. And all of the stuff going on in the spine rigging, there's a bunch of hierarchical stuff, there's a bunch of connections between things. Not everything that's going on, because there's nothing to connect it to other systems until the rig gets built. But quite a lot of it is already present in the widget when it gets brought in. And what the rig, and so what that allowed us to do was to basically make a lot of this rigging directly in Maya without having to necessarily code it all out. I mean, some of it is, but a lot of it isn't. And in retrospect, I mean, that has certain advantages. I mean, the basic advantage is it's fast to make it. Someone without an enormous amount of experience with programming can actually put that together, such as myself at that time, and frankly now too. Luckily, now I have people working for me who know a lot more about programming than I do. The disadvantage of that, of course, is that it's difficult to change, and it's not something that is especially maintainable in the sense that the TSM2 as it currently exists is a black box. You put in widgets on one side, it does a very specific set of procedures and spits you out a rig on the other side. And there's not a real easy way to change any of the basic ways that it operates because they're all sort of hard coded, as it were, in these files that TSM2 is importing in and then manipulating. For TSM3, we're going to do this the real way, which is pretty much how an auto rigger should be built, which is to say, it's all present in code so that it's more fluid and hopefully it'll be well organized and something that we can add features to very easily. Whereas there's a reason why we haven't come out with a TSM3 yet, which is TSM2 is not as easily extensible as we would like, and something that we're going to be improving a lot for the future. And you'll also notice that the widget is full of basically these things that will end up becoming your influence objects, and they all have an association of when the rig is being built and the mesh is being bound to those influence objects, where they will go in the hierarchy to then be controlled by the joints. But the widget itself is just a piece of rigging that basically duplicates some of what the rig itself will do, and allows you to manipulate it and position it inside the character. And the rig function looks for the hooks and knows what to do to hook them all up together. So that's the basic way in which this tool was sort of put together back in 2004 when I wanted to try to do another auto rigging tool. It's had more legs, honestly, than in a lot of ways I would have expected, given that it is something that really hasn't changed since then. And so I'm definitely looking forward to unveiling the new version, which will have all kinds of new things that TSM2 does not yet have. And I will actually show a few of those things tonight because I think that it would be interesting to give people a preview of where we're going to be going with things in the future. There's a couple of other things that are kind of interesting about the structure of the rig, or people might find them instructive or interesting in some way. So one thing that sort of we put together for TSM2, and this is sort of a trick, and it's something that's not actually all that hard to implement in one's own rig. I don't know how many people were looking at the innards of TSM2 and seeing how this worked, but the basic way that it works is not that difficult. And I know that I've certainly seen some rigs where people were implementing similar things. Not again that I should say nobody had ever done this before TSM2 came along, and that is the Stretchy. The stretching without IK popping, and the method that allows the arms and legs in TSM2 to stretch without doing the normal IK pop. So IK pop, if you're looking at this presentation, chances are that you probably encountered the idea, but I should just sort of mention it in case anybody hasn't. I see. Somebody has asked me a question, and I should approve it, and then I believe it will appear on the screen. Yes, there we are. When is the release of TSM3? Well, that's a good question. One of the reasons why, although we've made noises about releasing TSM3 for a long time, and have been actively in development on it for years, one of the reasons why it hasn't appeared is because as a production studio, we also end up doing paying work all the time. And, obviously when people come to you with work, you don't really want to turn it down. And so we haven't really had a chance to put the resources into it to finish it in the near future, or what would have been the near future in 2008 when we sort of started on it, simply because we've been too busy. And that's going to change because I've realized that there's no way we're going to get the tools that we're going to be doing in the future, TSM3 and TFM2 when we do the new version of the face machine, and Anzovin rig tools, which I may talk about a little bit, which is sort of the next generation. I don't even know if I like that term. The new thing that we are working on, that we're very excited about. We're not going to be able to get any of that stuff out unless we dedicate resources to doing that and only that, as opposed to trying to get it done between the production jobs that we're doing. And so I cannot actually say when TSM3 will be out because we're just starting to do that, just starting to figure out, um, how we're going to allocate those resources. And by resources, I mean people, because it's just a question of who's available to work on it inside the studio. Um, but I think that you'll actually see actual movement on the question of when is TSM3 getting released in the near future as we sort of overcome the problem of getting people to actually work on it and be able to finish the thing. So I can't say exactly when it'll happen, but I can say this time for real. This time we're actually going to do it pretty soon. And so, I mean, I hope we'll know. I hope we'll know in maybe a few months we'll be able to get a sense of when we'll actually be able to finish it and how long exactly it's going to take. Anyway, on to the next thing. Yeah, I was going to show you guys the sort of stretchy limb stuff. So IK pop. So if I turn off auto stretch, I think I had it on by default on this character. IK pop is the classic problem. You extend the leg, oh, it pops. You can't necessarily see it particularly well on this character because the legs are so thick. This is our mascot character there, by the way, Dennis the dog. You can't necessarily see it particularly well. You can sort of see it. Yeah, you got the frame rate to be able to see it. It pops when it gets to the extent of its IK handle. That's sort of a classic problem that everybody hates. Every animator on Earth curses that in some shot or other. Sometimes you can't really see it particularly well, but sometimes it's just incredibly obnoxious, and you have to spend a lot of time, tweaking things by hand in order to remove that little pop from the knee. In a simpler system for stretching a limb, you'll still see the pop. So if right now, obviously the limb's not stretching at all, but sort of there's a simple way to get limbs to stretch automatically to reach their IK goals. And that system doesn't really remove IK pop, it just continues to stretch the leg after the pop has happened. So I wanted to come up with a way of dealing with that. And I'd heard some ideas about how some people had tackled that in the past, although I'd never actually seen it done specifically, and I figured there was a way to do it. And I came up with a solution that seems to work reasonably well a lot of the time. Although it does have one disadvantage that we actually think we can correct for TSM3, which I will explain what that is. But in general, I've really enjoyed animating with that versus animating with a system where you do not have any choice about your IK pop, and it's just going to pop no matter what you do. So I'm just going to graph the incoming connections on one of these joints. You've got a whole bunch of stuff going through all of these nodes to finally input into the position of this joint. Specifically, there's two ways to do stretching. Well, I mean, there's probably more than two ways, but there's two ways that people use a lot. One is to scale the joint, one is to position the joint. And in TSM2, I went for position. Scaling just introduced a few extra things I didn't really want to deal with. And so if you look at where the translate's coming from, it's going through a whole bunch of different stuff. And ultimately, it comes back to this right here, and I'll actually have to open up the graph editor to show you this. Okay, so let me get this back on the screen in a way that you can see it. So this is a graph that, at least at first blush, looks like, and it's just an animation curve, it's actually a driven key, looks like it's just going up at a straight slope. And that's actually the slope that defines the level of stretch relative to the distance between the foot and the beginning of the beginning of the IK chain, the hip. And I just sort of figured out what that slope had to be and created something of that slope. But if you look very closely, you can see that it's not actually a perfect slope. It's actually a curve. And if this were a perfect slope, it'd end right here, but it doesn't. By pushing the point at which it begins back, and then sort of curving into the slope, I was able to get this effect where if I take this and you can see that it eases into the stretch. It's a little hard to see with this leg, but the difference is definitely there, where there's no pop, and the pop never really happens. Instead, you're getting an effect where the slope of the change with distance. Because I'm measuring the distance, I've got a distance measure in there, figuring out, it may not actually be a distance measure, I actually think it's a point constraint, and then I'm measuring its values, but same thing. There is I'm measuring the distance between these two things, and then I'm normalizing that. I'm turning it into a value of 1, being the default distance, and then I'm running it through that graph, so that as the distance grows, so does the position of all those joints grow in such a way so as to lengthen the leg. Um, and I kind of did that by eye, actually. I mean, much later on, Brian Kendall, who is doing some of the programming for TSM3 and Anzovin Rig Tools, figured out a math function that allows you to get that a lot more consistently, as opposed to tweaking a graph by eye until it looks right. But tweaking a graph by eye until it looks right is how I did it. And it worked out okay. It does have now there is a disadvantage to it. And the disadvantage is that because it's easing in, if your leg is pretty, which this leg isn't, so it may not be so obvious, but if your leg is pretty close to straight, sort of at your default pose, it will actually influence the default pose of the leg slightly. And it will do that because the closer, the system, essentially the closer you get to straight, the closer you get to straightening the leg and having the IK handle as far as it can go from the body with a straight leg. The closer you get to that, the more it has to ease into lengthening the leg slightly. And so if you have something that's almost straight and you turn on the auto stretch, then it will just slightly sort of push the knee out a little bit. And, so your default isn't quite your default anymore. And, that isn't really that much of a problem most of the time because, if you're animating and you're really expecting to do a lot of control over your character's, the lengths of all of your character's legs and limbs. And we're sort of building, or I was building TSM2 with the intention that the animator really would be thinking of those things. We have all of these controls that are built in. The knee slide, for instance, where you can literally sort of change the shape of the leg. There we go. Change the shape of the leg in a very specific way, and all of those controls and the bend controls were all built around the idea that the animator is going to be taking a lot of control over those things. So if you've got a pose and you know specifically what you want it to look like, you can always just sort of put the knee back where it was and put it exactly where you want it to be for that pose. Nevertheless, it's a little unclean. It's not really the best thing, and I think we actually have a fix for that in TSM3 where we can compensate for that so that your default pose will always be your default pose, but your the auto leg and arm stretch will still work. Also, we're just going to put in a switch there so you can do standard auto arm or leg stretch too. Obviously, it's not necessarily the best thing that you only get the option of no leg stretch or this kind of leg stretch in TSM2. It's been pointed out to me that you probably should just have the standard not easing in, not trying to correct for IK pop leg stretch too, because some people might want that, and better to include as many options in your rig as you can, as long as you're not, bogging it down too much. Certainly we're going to do it differently for TSM3, is that not all of the IK controls are in the correct space. Sort of a classic problem if I were to sort of switch this over to IK. So I switched this over to IK. So here's the thing: if I've got my handles here, and I'm just going to make sure that my translate tool is in local space, which it is. And you can see that the local axes of this IK handle, they're not in the world. They're not world aligned. And the local axes of this IK handle are also not world aligned. And the local axes of the upper body are. Not only that, but they're in differently sized spaces. So they're all in different parent spaces, and they don't relate to each other at all. And when I was sort of building the rig, I was always thinking about it from the point of view of how is an animator going to want to pose this? How is an animator going to want to think about it? Your default position is always 0, 0, 0. So you want to buffer your controls into a 0, 0, 0 position. And I was thinking about it very much from the point of view of a visual animator. That's kind of how I think about animation. And, the idea that you would want to just grab those controls and move them where they wanted to be for your shot, and you weren't really going to think about it in terms of questions of space and their parent space to quite the same degree. And that, to a certain extent, betrays my background as coming from starting my rigging career, working on Animation Master. So I don't know if you guys are particularly familiar with the software Animation Master, but it was pretty common for people who were sort of getting into animation because it was pretty cheap, and it was also pretty well developed as far as animation tools were concerned. In fact, in a variety of ways, it was very ahead of its time, and in some ways, it still does some things that Maya doesn't do now. In fact, specifically, it allows you to animate with quaternions in a way that is reasonable, which is a whole other topic. So I can get into that if somebody really wants to hear about it, but it's a whole other question. But everything in that package was very visual, and when I started putting together rigs, and that was where I first learned about rigging, I was always thinking about it in those terms. You didn't really think a lot about parent space. You didn't really think a lot about, you literally didn't think about rotate order because there wasn't, you're using quaternions, rotate order is irrelevant. Well, I don't know if it's exactly irrelevant. I don't exactly understand quaternion math perfectly, but the reasons why we care about rotate order as riggers don't really apply to an animation system where everything's being quaternion interpolated. And so all those questions there were a whole different set of questions with rigging with that software. And when I came over to Maya, I sort of imported some of that thinking with me. And this is one area in which it kind of tripped me up a little bit, because I should have been thinking about the fact that when you are, that's all fine. You're animating a shot, you're animating a character through a shot visually, and most of the time that is probably how you're dealing with animation. But sometimes it's not. Sometimes you have to do cycles. Sometimes you have to you want all of your IK handles to be in the same space because you do have to worry about how something is going to cycle over a long period of time, or you need to worry about how various animation tools are going to affect those IK handles. You're going to worry about what sort of because if I push the upper body forward 2 units, and I push the I can literally show you that. Like, I've got the stuff on local now, right? So I pull on the X handle. And look how they're actually moving in different directions, Of course, if I switch it to world, it'll move as one. But that's not actually the space your controls are being interpolated in. It's acceptable if you're just animating your character through a shot, and it's something that, sometimes you'll never notice. But sometimes it's just not right. Sometimes you really need things to be in the correct space and to be in a unified space. And that's certainly something we're correcting for TSM3. So, let me show you how to fix that problem. Or at least a neat trick to fix that problem. It has sort of its own sort of issues, but let me look at the hierarchy of this IK handle here. So, under my IK, so you'll notice that all of my IK stuff got moved into this node called IK, which includes all of my IK handles. That's probably kind of obvious. And you'll also notice that this node has no values on it. This node's in world space, and it has not gotten any transformation on it whatsoever. If I'm looking at right arm IK, there's several things going on here. So first of all, there's the control itself. The control itself is pretty close to being at position 0. I guess I should put it back straight to 0, but it's very close. Because it's in its default position. It's in its default position straight back at 0. That means 0 is its default position and should always appear that way to the animator. That's just sort of like a common sort of rigging technique. You always want things to return to 0 at their default positions. And to do that, I put a buffer on it. So there's a number of ways to do that, to set something up so that its default position is 0, 0, 0. And one of the ways is to use freeze transformations. Well, generally speaking, that's not actually a very good idea. Freeze transformations sort of does a trick, doesn't actually change the parent space of the object. It does a trick where it will basically, there's a separate set of attributes in every transform node in Maya, and it will sort of counter affect those attributes, and it'll counteract them, thereby making it appear that your new parent space is right at 0, 0, 0, but it's actually not, and there's all kinds of trouble you can get into using that tool. So I've gotten in the habit of any time that I want to freeze the apparent position of something, I create a null at that position, and then I parent the control to that null so that the control now forms 0, 0, 0, which hence is why the problem happens, because the null itself, which is of course creating its parent space, the parent space of the actual control, is now angled and not in world space, and hence this is why everything is messed up. So I can fix that though. I can take the RMIK null and I can zero out all of its stuff, which is going to put it into a kind of funny place that you wouldn't actually want to be. And then I can take right arm IK, which is also affected, and I can zero that out, thereby putting it back at 0, which then puts the my actual IK handle somewhere I definitely don't want to be. But that's okay. I can grab the buffer, which is now not rotated as a buffer. Grab the this null here. If I'm grabbing the buffer and sort of moving it back to where I would want it to be, I can create a new position for it to start with, which unfortunately turns the arm upside down. But leaving that aside for the moment, the nice thing about this, and you can set this, you can therefore set its default position to be whatever you want, and its default space to be whatever you want just by manipulating that null, is that the IK FK switch tool that we wrote is actually robust enough to take that into account. Through it wasn't deliberately coded that way, but we did try to make it at least somewhat robust, and so therefore it actually still works. So if I were to grab this and do an FKIK switch, it will actually still work. It will still FKIK exactly as you would expect it to. And if I then repose the character in some other way and sort of whatever, pose it in some fashion or other, and then swap it back, you'll see that it will work even in that new space. And again, if I return this to 0, it's still going to put it back in that sort of funny position. But this, depending on what your needs are, you have the option of going in and sort of changing that around and figuring out what your parent space should actually be. And that's just a nice trick, and something that can be quite helpful for certain kinds of projects. So that'd be the most common thing that I'm basically is a critique, a very valid critique of the TSM2 rig. What are some of the others? It's not really quite as efficient as it could be. You've, I'm sure, seen this enormous network of hypershade nodes, and that's just on a single bone. There's a whole lot of them. That actually runs a lot faster than trying to do all this in expressions, but that really large group of nodes could be culled by some degree, and we're trying to tighten it up and make it more efficient for TSM3. There was more of an issue when TSM2 was first released and hardware wasn't quite as fast. But still something that we wanna improve on. We want to make it more efficient. We want to make it faster. We expect drastic speed increases once we actually get to Anzovin rig tools and getting that out the way that we want to. TFM, specifically about its auto-skinning algorithm. So, sort of as a little bit of background to that. So TSM2 does auto skinning. It does some auto skinning, but the auto skinning that TSM2 does is not very advanced. It's a little better than Maya's, but you still end up having to paint a bunch. And but we never really came up with anything that was especially useful. Now, for TFM, however, and this is really due to Brian Kendall, who's pretty much the unsung hero of TFM. What he had done was he actually wrote an algorithm, and personally I don't understand how it works. I don't even have the math background to understand how he's doing that. That basically traces the edges well, basically traces all of your edges, and figures out, it's looking at a mouth, for instance. It traces around inside the mouth, and it looks at all of your edge loops. And I'm not even sure if it's edge loops. One of the things that he was quite careful about was trying to make sure that it is robust enough even to work on geometry that wasn't especially well modeled and didn't have clean edge loops. And right about the time that we were working on that for some of our production jobs, we happened to have some examples of some stuff that we'd gotten to work on where we'd been provided with models that, to say the least, really didn't have proper edge loops at all, and were not very well modeled at all. And so we wanted to try to make it work on stuff like that too. And he did something, again, that I don't fully understand, where it went in and traced it, and it fairly well understands the topology of the geometry, and it can figure out the difference between an upper lip and a lower lip. It is pretty impressive, and it works on about 99% of characters. There's still about 1% it doesn't work on. It might be a little more than 1%, but it works on most characters, actually. We've had very good results with it. And, sometime I should get Brian on here or something to talk about the stuff that he devised, because it's very clever. But unfortunately, I do not really understand everything that went into that. Now, for TSM3, we're talking about implementing something called heat equilibrium weighting. There's a paper out there on how this was done, and it's a pretty interesting method of pulling some really good weights off of geometry. And we haven't actually started working on that, so I can't say for sure if it'll be there or if if it'll work out for what we want to do. But it certainly shows promise, and that might mean that you end up getting very much closer to what you'd actually want weights out of TSM3 than you get out of TSM2. Was it more difficult to create TSM for Maya compared to TSM for AM? Well, yes and no. It was both easier and more difficult. Maya has the advantage of really being built for scripting and really being built for tool making, and AM was really made for. It really wasn't made with that kind of pipeline design in mind. It was. I mean, they had a plugin. They had an SDK, and we used it, and it worked. But it didn't allow you the kind of wide range and control over things that Maya does, and that's of course what Maya does especially well, and it's why when you build production tools, you usually end up building them in Maya. One thing I will say about AM, there were a lot of ways in which the way that you dealt with rigs was very direct. And so it was easier to come up with rigging concepts in AM in a lot of ways than it is in Maya. There's a lot of things to keep in mind in Maya, and the flip side of Maya's power, of which there is a considerable amount, and I really do love Maya rather a lot some of the time. The flip side of Maya's power is that you really do have to know what you're doing. When you're looking at how to build a rig, when you're looking at how things manipulate, it allows you to do pretty much anything you want, and which means that you can easily make a rig that's very inefficient. You could easily make a rig that doesn't work well. You could easily make a rig that is significantly broken in some way or is going to crash. If there's all kinds of stuff you can put into a rig that is basically just not a good idea, and it relies on your knowledge as a user of how to avoid that. In that respect, and coming up with good rigs for Maya can be more time consuming than it was with Animation Master. On the whole, I would say, at least where I am now, after I've used Maya for quite a long time, the power that gives you of being able to essentially do whatever you want, within certain limits, and really design it to act in a wide variety of ways. That power is ultimately pretty important. And anytime you're building something that's going to be hammered on by real production, you really want the ability to really define in every way how it's going to operate. So I just showed you, one of the tricks and things you might want to modify TSM. Here's another sort of useful thing that you can do, useful trick that you can do for manipulating spaces and the way spaces work with TSM. So one of the things that that I was talking about, how all the systems are isolated from each other, and how they're not. We wanted to allow the animators to manipulate one thing without affecting another. So one of the basic ways that operates is you give your rotation isolation. That's what I called it then. Nowadays, there's actually a name for that, and we call it space switching. And it's actually a pretty common thing to do. At the time, I came up with my own name for it, but people do this all the time. Basically, what that does is it means the rotation of your arm is isolated from the movement of the body, but at least by default, it's not isolated for the movement of the upper body control. And that's a pretty common thing to want to do in a rig, but it's not necessarily the only kind of isolation that you would want. If one had a more comprehensive, space switching control, as some modern rigs have shown, you'd be able to switch it between a variety of different spaces that it would operate in, and that could go for IK controls too. But there's kind of a trick that you can use, which is that all of that isolation, it's all being done through orient constraints. And it's all being done through orient constraints that are actually, in the hierarchy in a very specific place. If I look under the upper body, left arm rotation isolate, right arm rotation isolate, head rotation isolate, all those things, there's a node inside the rig. It's getting oriented like these things so that it will basically follow their rotation, but not follow the rotation of anything else. And therefore, I can take left arm rotation isolate, and I can deparent it if I want to, which means that now it will not be affected by the position of the upper body, or I can parent it to something else. I can parent it to anything I want, actually. Um, and that's or I can create a constraint to it that I can drive with between multiple targets, or you can pretty much do anything you want with it, and that's kind of a nice thing. And certainly for TSM3, one of the things we'll definitely be looking at is we want to be able to allow you a better space switching set of tools. And you can see that in rig demo reels out there. People have come up with some really good ways of space switching your various controls, and TSM2 sort of did the rudimentary version of that, and we can push that a lot further. But in the meantime, you can always grab that null and do something else with it. Switching for things like IK hand switching between head, hips, and chest controls. I actually think that if I'm understanding that question correctly, you're basically just asking me about space switching, and basically, switching between if the IK hand is affected by head, hips, and chest controls. The answer to which is, yeah, we totally want to get space switching. And if you wanted to do that with TSM2 right now, though, you can, basically along the same lines. If I look under IK, you can see that these all have nodes under which the IK is parented. And you can therefore take those nodes and put them wherever you like. By default, of course, all they do is sit there inside the rig, and they're all in world space. But you can parent them to something else. If I wanted to get, if I wanted the right leg to move with the upper body, I could parent that control over there, or I should say, I could parent that buffer over there, and then I would have something where I've got an IK control that is moving relative to the there we go. You can see that a little better now. That is moving relative to the upper body control. And again, yeah, I mean, we want to have a better way to set things up. We want to have a better way to space switch like that in TSM3. Probably would have had one in TSM2, but it's quite old now. And back in 2004, there was a whole lot of other stuff we were putting in here that was at the time seemed pretty advanced and is, certainly pretty common now. So here's another neat trick. If we want to look at the spine, if you guys are familiar, some of you probably might be, with a Schlifer spine named after Jason Schlifer, who is famous for doing a variety of things, including rigging Gollum in the Lord of the Rings movies. And he did some presentations on that, and published a disc through what at the time was Alias, in which he sort of explained his methodology for that, and it came to be called, at least in my, a Schlifer spine. And the idea there being, you grab the upper body, or you grab the pelvis, and you are able to move this around independently, or move the pelvis around independently, and do whatever you want with it, and it will stretch the spine in between, and you can even have something in the middle to affect the curvature. Basically what we have here in TSM2 pretty much is a Schlifer spine, but it has a couple of interesting things added to it that are kind of, I don't know, they're kind of interesting, and they might be useful to somebody. So first of all, the concept behind a Schlifer spine is that you measure the distance of the curve. So you've got a curve. This is spline IK. So there's a curve. There's an actual NURBS curve in there that through clusters basically is being attached to either the upper control or the lower control. So that's what defines the curvature of the spine. That's why it stretches. But of course, if you just use spline IK normally, it's not actually going to stretch. It's not actually going to change the position of the joint, just the rotation. And so obviously, we have this thing, and it is stretching around. So, it is in fact, figuring out what the positions of all of those joints need to be. And the way that he set that up, the way that was that he measured the length of the curve, and basically divided it up. Figured out basically how far away from true it was, how far away it was from default, and used that to basically scale all of the joints. And so that's what I'm doing here. So if I were to grab one of these spine joints here and look at my inputs, there's a bunch of other stuff going on in here, which I can sort of talk about some of that if you want. But the part that's actually important is, so there's a node here. This is called a curve info node, and the curve info node basically measures the length of a curve. That's its entire point. And it's not actually that commonly seen, except in this situation we were trying to build one of these, because you have to get it through mail. I don't even know if there's a command in the interface to make one of these. So it's a little bit, not obvious. And what it does, though, is it gets you your arc length. This tells you how long your curve is in world space, which is actually relevant in a moment. And so what you can do is you can divide that input. So we're finding out the length of the curve. And what I'm actually doing there, well, I'll get to that in a moment, but when I get over to this math node here, what I'm doing is I am taking the number that it gives me. So if you look at this now, you can see that it's a number very close to 7 being divided by 7. And what's going on here is that I am measuring the length of the curve. Basically, and then dividing it by itself. And what that does is it normalizes the length so that the length of the curve is 1. And if you make the curve 1.5 times its original length, then the number you're getting out of that is 1.5. So that can be a scale value that you can apply to all kinds of things. Now, between that, though, I've got something else going on here that is taking that number and I'm dividing it by something else. Now, what that something else is basically a little trick to take your Schlifer spline, take your measurement of your curve, and make it something that allows for you to scale its space. Because the problem that I was just talking about, where the length of the curve is measured in world space. But if you were to scale up your entire character, then you are basically moving your whole character around. You're scaling up the space of the character, but the measurement of the curve won't stay constant. It won't stay the same. The values coming out of it won't be the same, because even though its parent space has been scaling, meaning that the values of the curve or of anything else going on in the rig aren't changing, the value of the curve, the length of the curve is, because that's always measured in world space. So, as I'm measuring that in world space, I can actually show you what would happen. And this is sort of what would happen conventionally with this sort of system. Let's say I were to take this system here. Let me just go into the multiply divide, copy this number, break the connection, and then restore the number. So that's basically the whole system as if this section right here was having no effect. And I were to scale up the spline would still work fine, as you will see in a moment. If I were to play around with it, it'll still do what it's supposed to do. But if I were to scale the character up, you would get some unintended results. You're sort of, yeah, see, that doesn't really quite work the way that you would want it to work there, does it? It's totally messing with everything. And the reason why is because it's measuring that in world space. So what this is here is I've got a distance measure. That's what I've got right down here. It's just a standard distance measure, just measuring the distance between two locators in world space. And that distance measure is parented to the rig, so that when you scale up the rig, it's changing those values. So if I guess, I don't know, I could undo it, but I don't know how many times. Let me just put that back where it belongs. And now you will notice that I can scale up the character without causing any ill effects whatsoever, and I can still use it normally, which is something that with your typical Schlifer spine doesn't work. And all it's doing is it's using those two locators and the distance between them to keep the by dividing your actual your actual curve, the length of your curve by that, you're accounting for the change in space. You're removing the world spaceness, I guess. I don't know. I'm trying to think of a good way of explaining it. And by doing that, you're meaning that you get to scale. You get to do whatever you want. And so it's just kind of a nice trick, and it's a nice thing to add. And the other thing that we had added to the Schlifer spine that was not part of its original design, and I remember being quite proud when I first came out with TSM2, and Jason Schlifer said, "Oh wow, that's pretty cool," and I was like, "Yeah," but basically it allows you to have a scale effect, and a scale effect that's propagated up and down the curve, up and down the set of joints that are in the spine, and that's a pretty nice thing if you want to be able to manipulate a whole bunch of aspects of your character. And, of course, most of the time spines are spines. That's what the widget is called. But you can use it in a variety of other ways. I mean, you can use it for limbs if you want to. And it lets you have a huge amount of control over all of the things that this sort of aspect of the spine is doing, and you can sort of stretch it and squash it and move it around and have really like lots of control over exactly what it's doing and really change its shape a lot. And that was something that I really wanted you to be able to do. And again, this is something that I had seen in the Chicken Little rigs back in the day, and realized that was where animators wanted to go. You really wanted to be able to control the shape of your character. There's a lot of other things you have to think about when you're making a rig. I mean, one of the things is maintainability. How is it going to fit into your pipeline? How is it going to, how well is it going to operate? How fast is it going to operate? I mean, there's a million things to think about when you're making a rig, but ultimately, the real goal that we all have when we're making rigs is what can we allow the animator to do, and how are we going to make it possible for them to create the performance that they want to create. So this was sort of part of that, and that's actually how that twist is, or how that scaling up and down the spine is propagated is I mean it's not that complicated actually. So I'm just going to grab a joint and graph its inputs again, and sort of looking through some of the stuff in here, and one thing is that this is being driven. So I've got spine joint 4. And these are its parents, but this is the one that I'm concerned about, spine rig joint for. Because of that separation between joints and rigs, I have actually, in many cases, a duplicate set of joints because I'm going to be doing a bunch of things to them that I don't want to have happen sort of in the joint layer. And so here's a case where I've separated those two things. It's just getting a direct connection from a different joint that is a duplicate of itself. And these are all the things affecting its translate. But there's a whole different system affecting its scale, because one of the reasons why I wanted to use translate to do the stretchiness of the spine was so I could use scale to do this stuff. So it's grabbing the scale out of, say, the middle translate, which I've got right here. It's grabbing the scale out of it, and it's putting it through a couple of math nodes, and then spitting it out basically into the rig itself. Now, you'll notice that there's actually a transform node sort of stuck in here, sort of in a weird place. Like, what is that transform node doing there? It's not actually transforming anything. And basically, what it's doing is I'm getting the scale coming off of here, and I'm plugging it in there, and it's actually sort of holding that value, and I'm pulling it off to go in a bunch of different places because of the fact that I've got a case where I want to diminish the scale or essentially blend it between different things. And so I'm getting that scale value for every one of those joints. That value is getting blended somewhere along the way. Now, if I actually had this to do all over again, I'm kind of looking at this structure, and honestly, this is one of the places where I could probably make it more concise, where I could probably make it more streamlined. There's a use for blend color nodes specifically, which are very useful in rigging that I wasn't using here in my original sort of version of this. That honestly, would simplify this rig structure a fair amount. So there's another question up here, kind of related to what I was talking about before about 3D animation becoming more like 2D animation. Have I ever considered adding a smear frame function? So that's actually kind of an interesting idea. So all of the stuff I've been talking about rigging-wise has been about sort of being able to reshape your character in the same way that if you're drawing something in 2D, well, you draw the character in a pose. You don't think about rotating joints. You don't think about the mechanics of rigging or how the rig operates or how the hierarchy operates. You pose the character, and because you're drawing it, it does whatever you want. And so there's a bunch of techniques in 2D animation. You can smear a frame or sort of change the way something looks to lead into the simulate motion blur to a certain extent. Lead into the frame before and after. There's all kinds of like neat 2D tricks that we don't really get to use in CG very much. We sort of tend to rely on real motion blur. So on the one hand, there's different ways to approach that, and some of the ways are rendering based, which is sort of beyond the scope of what we're talking about here. But there are certain rig-based methods of stretching between essentially what you've got on one frame, what you've got on the next frame. And I haven't really investigated them, but I do think they're very interesting. Essentially motion blur sort of by distorting, which is much more of a 2D kind of look sort of thing rather than a 3D way of doing things where your motion blur is literally rendered and operates like a camera shutter, is kind of an interesting idea. And I haven't really investigated that, but I think it's a pretty cool thing that I would probably like to investigate at some point. So why don't I talk for a second about the twist switch? So I was sort of the twist switch is a method of dealing with how do you deal with the problem of, well, pretty much the problem of a shoulder. It's something people deal with all the time in rigging, and there's a number of different possible solutions to it, and this is one of them. Where basically you're talking about your shoulder, and you're talking about basically what's going to happen as you propagate the shoulder, sort of propagate the twist of whatever it is you're doing up and down the shoulder. Because, of course, in a real arm, if I bend my arm and then I sort of rotate it up like this, it's not bending the arm this way. It's twisting the arm, and that twist, that deformation of my actual arm is propagated or interpolated, or I don't know, kind of thinking of the best way to sort of describe it, but it's not all happening right up here in the joint. And sort of your simplest idea of a rig, you have some joints and you have some point weighting, and you do some stuff to them. Sort of has a lot of problems, and some of those problems come out of linear blend weighting being the dominant way of doing things, although that's changing now. I mean, my 2011 just got dual quaternion weighting as another way of doing things. Being things are sort of twisting up and sort of losing volume because linear blend weighting doesn't deal with those sorts of situations very well. But even that aside, even if you have a better method, even if you're using dual quaternion or something like that, you still don't want the deformation all happening right up in your shoulder because well, basically just because that's not how actual arms operate. Even on a cartoony character, it doesn't often tend to look that good. You kind of want to spread that out. And the problem then is figuring out what happens, what is the difference between the rotation of the shoulder and the rotation of the upper arm, as far as in a purely twist related way. Basically, that's a very common problem in rigging. Because what you typically get is it's fairly easy to say, oh, so I've got something in here, and I'm going to aim it at my elbow, and so it's going to follow along, but it's not going to twist, so that I have something that I can that I can interpolate between. And the problem that you get out of that is your up vector. So anytime you're aiming one thing at another thing, you have to have an up vector to tell it, because there's an infinite number of different rotations that you could be getting just out of a single vector for an aim. You need the up vector to tell it how to roll, so to speak. You kind of have the, you kind of think about this as like, you have this gesture. This is the rigging gesture, right? It's three. This is the special rigging handshake because it's all three axes. And basically you're pointing one at something, but you don't know how it twists until you give it an up vector to tell it, where to stabilize at. The problem is you can put your up vector over here in front of your arm, and then when your arm moves forward past 90 degrees, it's going to pass right over the up vector, and then your arm's going to flip. And you can or you can set it up so your up vector is sort of below here somewhere, and pass your arm, sort of past that, and then it'll be fine, on this axis, but it's not going to be fine on that axis. And the method for so that isn't always a problem for every motion that you're going to animate, because some things aren't going to pass those barriers. But a lot of things are, and you want to give the animator as much freedom as they can possibly have without mangling the mesh in some horrible way. Put it back the way it was, and show you what I'm talking about, because it's pretty easy to see the problem. I can sort of, let's see, I put the attribute where you choose that on the hand for some reason. Probably a better way to make that accessible, actually. And you're looking at twist placement being up. That means I can rotate it up and down as much as I want. I can rotate it past 90 degrees, and it will never twist. Right? Okay. But I can't rotate it this way without twisting. Oh, look at that. Suddenly, bang! It passed the up vector, and now it's going to flip out. And the method that I had come up with for this was to basically allow the animator to sort of choose which one they wanted, and to change that in the middle of a shot, even if they wanted to. Although, frankly, lots of shots are not really going to let you do that. But to allow that at least possibly, and you can just change your twist placement from up to across. At its most basic level, I'm basically switching an up vector. I'm basically changing what that position is, and then sort of reconfiguring the other things in the rig so that it will still be everything will appear to be oriented the same way, even though the up vector is just changed. And the system, I mean, I could trace back through the whole system, but it has got a lot of elements to it, so I don't want to take too long. But I can show you. This is one area where I kind of wanted to show you something that TSM3 is going to do. This is something going into both TSM3 and Anzovin rig tools, and obviously this is a very simple test. But this is an aim without up vector system, and it allows you to aim stably without an up vector. So you'll notice, I can push it past, and it flips it 180 degrees. But how often do you put your arm straight back for your character, right? Okay, so I can do this. I can go past 90 degrees in either direction, nothing flips. Or I can go past 90 degrees in this direction, nothing flips. Look at that. It is an aim with no up vector, but it's still stable. And that's something that I'm going to be putting into both, because you can do it in Maya, with this rig system, which I'll sort of let you look at that a little bit. It'll go into TSM3, and they're basically that problem basically won't exist. And then we've also coded up a version of it that goes inside a node to put in Anzovin rig tools. Basically, one of the things we'll be including with that is an aim without up vector constraint. And the way that it works is, I don't know, I think it might be kind of useful to people. Basically, it's got a bunch of things going on here, and it's done with these 3 joints and some IK handles. And basically, these IK handles, I'm just using them as an aim at, with an up vector, actually. I'm using them as an aim at because if you get a rotate plane IK solver, which is what Maya does, and you apply it to just one bone, then it will basically act like an aim with an up vector, with the pole vector as the up vector. And I just find it a little easier to deal with and a little easier to visualize than the aim constraint. So I use IK handles for that stuff sometimes. But basically what's going on here, at least notionally, is I'm converting to spherical coordinates. And that sounds kind of difficult to describe, but it's actually pretty simple. Basically, the idea is that I've got one, let me sort of use my hands to show it a little bit. So I've got a thing that I'm trying to aim at, right? So it's this point right here. And I've got something I'm trying to aim at it. So conventionally, I point at the thing, but without an up vector, I don't know what's going on. I need to have that up vector to tell me where to point. But if I have an initial position for the thing that I'm aiming at it, and I basically instead of doing that, I say, okay, I'm going to instead sort of, a good way of describing it would be, so I have this position. It's got my 3 axes actually, but it's just some initial position. It doesn't have any sort of aim going on, and it rotates one of those axes to point at that object. So this is a one-dimensional aim. So it's completely stable, because no matter where that thing's going, there's always going to be a one-dimensional sort of, I just have a single rotation to get this aiming at it. It's completely stable. I mean, it can still flip if you push the thing in the other direction, right over the top, it can flip around. But, it's not going to, there's no need for an up vector. And then I can say, and then there's basically a longitude. You can think of it as latitude and longitude, right? This is then going to get its own one-dimensional rotation to point at it that way. And it can only move around like this. It can only move on one dimension. And then it's going to point at it. And just aim at it a little bit. So now I've got something that's stable. It's following it around, and every time I move it up and down, that one-dimensional aim will be working, and every time I move it around like this, the whole system swivels to follow. Then I've got a joint right at the end, right on top of that then counter-rotates all of the swiveling to follow that I have going around here. all of that sort of swivel to follow, and so all of those things are stable, um, and all of those and but you still haven't dealt with that counter rotation, that counter roll. What that's doing is it's making it possible for the fact that it's basically nullifying the effects of the whole system swiveling around, so that everything remains kind of stable, and you're left with the idea that this thing's following around, but it is maintaining its original op. And that also means that because that's being compensated for, if you put the object that it's aiming at, if you put it like over the top so that the whole system is going to flip around suddenly, well, it actually doesn't flip around suddenly. I can totally do that because every time you're sort of putting it over the top like that, and all of its rotation there is being compensated for, so that flip effectively never happens because you're compensating, so you'll never actually see a flip. That is, every time it gets rotated this way, the thing at the end here rotates the same amount in the opposite direction. So there's never a visible rotation going on there. I hope that was actually clear. I hope that was actually something people can understand. But it's a nice trick, and I've seen people try to solve this problem in a lot of different ways. I've seen people do some pretty crazy stuff, actually. And there's some sort of like deep quaternion math that you can use to solve this problem, too, that I don't understand at all. Basically, there's a whole lot of methods people use. I mean, I investigated a lot of it when I was trying to figure out how to deal with this problem in a stable way. And there's some methods that basically have you do a rotation from two different up vectors and then blend between them depending on the position of an object. Kind of works reasonably well up to a point, but sort of gets in trouble the closer you get back to the sort of back pointing backwards, whereas this system will flip right there. But that's really far back, and anywhere out here, this is all pretty stable. There's a bunch of other there's a bunch of other methods that I've seen going on here. I don't know. I mean, I think the system works pretty well. I hope I've managed to describe it in a way that actually allows people to tell sort of vaguely what's going on. But you can see the hierarchy right here, and it's pretty simple. You just have your roll, and that's got a IK handle on it with a pull vector to this IK handle right here. So it's rolling around. You know what I should do? If I want people to actually be able to see, what is going on, I should kill the counter roll, so that it will be more obvious what's going on. So now that I've done that, you can see what's going on here without the counter roll. Basically, I'm moving it around, and wherever it's going, and see there you get your flip where you move it over the top, right? Wherever it's going, it's completely stable, but it's also twisting in an odd way, like these two things. And the important thing here is to have the tip of this and the tip of that be as close together as possible. So the counter roll is what makes that possible. Let me just undo all that stuff I just did and put the counter roll back, and yeah. So I think that's now got the yep. Having the counter roll there means that it's still stable, but you'll notice these 2 points are basically always staying very close to each other. And that's what they do. And, I mean, it's a nice trick to deal with that problem. What do you think is necessary to simplify in TSM, Jim? There's a bunch of stuff that needs to be sort of simplified. And one of the main things I think is that I'm gonna redesign the rig to make much better use of 2 things, and one of those things is blend color nodes. Blend color nodes are incredibly useful from a from a rigging perspective, and I can design the rig to make better use of them, and need somewhat fewer, therefore, multiply, divide, and add subtract nodes. That's one thing. I can just cut like some stuff out of the overall graph by doing that, I think. Another area is more use of driven keys. So Jedediah Mitchell, one of the people who works on rigging here, he once set up a test where he set up a basic transformation using a couple of math nodes. It was like 3 math nodes or whatever, and then did the same thing with a single driven key, basically setting the slope on that. And incredibly, the driven key, a driven key isn't faster than a single math node, but it's faster than I think two. I'm trying to remember exactly how it went, but basically, if you've got something where you can reduce a couple of math nodes to a driven key, you pretty much should, because they evaluate really fast. They evaluate a lot faster than an expression doing the same thing. Basically, I mean, those are two main things. I mean, there's a bunch of other areas where there's some redundancies in the rig. There's probably some extra constraints you don't really need. There's just a bunch of areas where it can be refined. And I'm not going to say that you're going to get a huge speed gain out of that. You might get a 20% speed gain. I mean, and that's just making up the number. I don't really know, but I suspect something along those lines. And the sort of the speed gain though. I mean, that's still a pretty significant speed gain. Um, and the area where I think we'll get the real speed gain when Ansible Rig Tools comes out is basically taking a lot of that stuff and collapsing it into be compiled in C inside a node, and that'll run a lot faster. As an animator, what possessed you to learn this crazy task of not just learning to rig but create TSM? Well, so my background, well, I don't know. My background's a little weird. I've been both an animator and a rigger in a lot of different situations, and honestly, rigging, though something that I do a lot, is probably not the thing that I like the most. I would actually rather be animating in some ways, but which is why I now have people that I can pay to do a lot of the rigging. But the rigging, the reason why I kind of got into it was really two reasons, and one was that it's actually kind of enjoyable. I mean, making rigs day in and day out can be wearing, it can be difficult, and that's why auto rig solutions are so common, and that's why in any real production pipeline, in any situation where you're making a feature film or you're making a game, the people in your rigging department, they're not sitting there making rigs all day. They're sitting there making rigging tools all day in a lot of cases. They're sitting there making your pipeline tools and making sure everything works together. And the rigs are often going to be generated out of a whole bunch of scripts that they've put together. And those won't be auto rig tools in quite the same way that TSM2 is an auto rig tool. I mean, they're not black box, something that, somebody who doesn't really know a lot about rigging, doesn't know a lot about scripting, doesn't necessarily know a lot about the internal workings of Maya can effectively use. And if you're making a pipeline, if you're coding a pipeline, if you're sort of in a bigger production situation, you're not going to want to spend a huge amount of time. Those tools are going to be made for you, and they're going to be made for your needs specifically. And so they have a slightly different sort of direction than something like TSM2 does. The reason of coming up with TSM2 after I spent some time doing rigs for myself, and both because it's kind of enjoyable to come up with like new rig ideas, and it's kind of enjoyable to sort of figure out how to make something work. People tend to think of rigging as being sort of a horribly onerous task. And it can be a horribly onerous task, but it can be pretty rewarding too in some ways. I mean, coming up with a system and making it work, and sometimes banging your head against it for a little while, but then finally making it work and sort of seeing the fruits of your efforts, it's a totally different kind of enjoyment than one gets out of animating a shot, where you're hopefully you're not dealing with technical problems. Hopefully you're not dealing with things on a technical level. You're just trying to make your shot look good, and that's a whole different kind of sort of approach to things. And I do enjoy rigging to a certain extent. And I saw that things could be better, and I wanted to create a better system for myself. Then it sort of had come up in some conversation that this concept of making a rig automated could exist. And I was like, well, somebody should do that. And when we'd come up with the first version of TSM for Animation Master, it was because lots of people were trying to make, I'd released some rigs to the Animation Master community. It was a very tight-knit sort of community. And people really liked them, but it took a lot of effort to make a single one of them. I mean, I literally think I spent a couple of months on each of those rigs, just doing that. And, that's, if you want to get to be animating, that's probably not exactly what you want to be doing. And I thought that maybe there was a market for coming up with a tool like this, and there was. It was very small. It got a lot bigger once we moved to Maya. Honestly, I didn't entirely expect TSM2 to be as widely used as it is. I figured we had a couple of years before the market for doing this was going to explode, and people were going to be marketing these kinds of tools all over the place. And I turned out to be wrong about that, for which I am quite grateful. Certainly there are plenty of auto rigging solutions out there. I mean, there are a bunch of freemail scripts, and we're not the only people selling solutions either. But TSM2's had a good long life, and people have really used it, and people have really had good experiences with it, and it's really helped a lot of animators, get a rig that they wanted to use, and that's something I'm very proud of. But its life is definitely coming to an end. TSM2's old now. It worked well for its time, but TSM3 is going to be a lot better. And a lot of that's going to be on the technical end of this hack that I just described to you of how I had a bunch of that rigging sort of inside a file, and then it all gets assembled. Not actually the best way to make a maintainable rig. Not actually. If you're in a production environment and you're making an auto rigging solution that way, you probably shouldn't be. You should be doing it the real way. Because you want it to be something that you can change very easily. And, this is not something that it's so easy to change in the middle of a production. And we want TSM3 to be something where we can keep adding to it very easily. We can keep it can be architectured well, so we can keep sticking things in it, and adding new tools and adding new systems, and not have it be as difficult to add new systems as it is with TSM2, which is it works, but it's kind of ad hoc. Are we considering an auto-rig solution for non-organic models? Well, basically, no. And I think that's actually a really interesting idea. Somebody could do an interesting auto-rig solution for inorganic models for, whatever, cars, trucks, airplanes, all kinds of stuff. But there's a lot of problems that come up with that. I mean, one of the things about at least body rigging for characters is that it's pretty character independent. I mean, within a certain stylistic bounds, a character arm acts like an arm. You've got some idea of what it does. And if you're animating, it's somewhat mesh independent. You're deforming the mesh. And when you're animating, or you're rigging up, or you're some sort of car, or there are certain things that are going to be similar. I mean, you're going to have wheels. You're going to have a steering wheel. You're going to have, some things that are basically similar, but the range of constraints on what you're creating are much wider. I mean, you could be creating, it's like, let's say you have a mech or something. Well, depending on exactly the way it's modeled and exactly the way it's designed, its arms might work in a completely different way. You might have to, consider specific limits on how you're moving based on interpenetrations in the model, because you could have this. Who knows? Who knows how you've designed your mechanical model? And I'm certainly not going to say it's impossible to come up with a good toolkit for creating those sorts of things, but it's not something I've put a lot of thought into. And maybe it's something that once we get TSM3 and Anzovin rig tools out, we might, and TFM2 and all the things we have on our slate right now. It's something I might think about, but it poses some kind of unique problems, and they're kind of separate from the problems of how are you going to create a consistent way of doing creatures and characters. And so it's not something we have on the table right now, basically, and that's what I can say about it. With more auto rigging solutions coming up every day, how do you think that affects riggers' jobs? Well, I'm going to say, at least as far as the kind of auto rig solution that TSM2 is, I think it's, at least in the big production area, pretty much not. When you get down to making something streamlined in a pipeline, when you need to be able to change it effectively, when you need to be able to integrate it with whatever the other departments in your pipeline upstream and downstream are going to need, something that's a black box like TSM2 doesn't really threaten your job at all, because you need to have control over that. And you, as a rigger, need to be able to adapt your tools and what you're doing to what everybody else is going to need, everybody else in your production. And TSM2 isn't really designed to let you do that easily. TSM3, for all that, I think it's going to be a lot better for TSM2 than TSM2, and I think it's going to be something people are going to, is going to allow for certain things that are kind of difficult for TSM2, and going to be more efficient, and certainly going to be easier for us to update. It's still going to be a black box. And it's not going to take anybody's job who's working in sort of higher end production. Now, Anzovin rig tools is something a little different. Anzovin rig tools is not an auto rig tool. Anzovin rig tools is a new set of bones and IK handles and deformers that do things that Maya completely does not do yet at all, and which replaces a whole lot of rigging functionality that you'd have to build a whole system to do right now with a single node. and a single node with a whole lot of settings and ways that you can manipulate it. And I don't think that's going to take anybody's job, because what I'm hoping for is that people will want to use that within their pipelines, but unlike, it's not a black box. It's not something where it's like you put in a mesh with widgets and you get a rig out the other side. It's something where here's a whole new set of tools for you to use. And you still need to, you could use it with TSM3 actually. One of the ideas is that TSM3 is going to build, standard Maya rigs. And it's also going to be rigs built with the Anzovin Rig Tools node. It's going to do whichever. And so if you have both products, you can build an Anzovin Rig Tools rig with TSM3. So you can do it black box. But you don't have to do it black box. And if you have real needs for your production, where you need to be able to reconfigure rigs, so it might make your job a lot easier, depending on exactly what your job is. So that's the hope, anyway. If you need rigging software right now, buy TSM2, because I'm going to tell you, I'm going to guess TSM3 is sometime in 2011. Maybe early in 2011, but I really don't know. Will TSM3 allow for adding and subtracting arms and legs, allowing for asymmetry rigs? Well, TSM2 actually allows for that now, at least if I understand what you're saying correctly. You're saying if I go to basically build a part, and I build, say, a set of arms, I can choose to build both, in which case they're mirrored, or I can choose to build right only or left only, and if I build right only or left only, I can just build an extra right arm and stick it on to the character if I want to with TSM2. So TSM3 certainly will allow for that. TSM2 does too. One thing that TSM3 will allow for that TSM2 doesn't allow for is you'll be able to go back and change things after the fact. So if you create a rig with TSM3 and then you do a bunch of weight painting and then you realize you want to move the position of the shoulder joint, you will be able to regress to the widget stage, keep all your weighting, reposition your widget, re-rig, and restore all of your weighting as part of the package. Now you can do that now with TSM2 if you want to use some sort of script like the Comet Save Weights script, or any of those other methods of saving your weights. I mean, you can already do that, but it's a chore. TSM3 will do that in a very streamlined way. At any time, you can return to the widget stage, reposition something, and just flip back to your fully rigged model. Certainly when it comes to Anzovin Rig Tools, things we're releasing a little further away, certainly using the Qt tools will make interface building a whole lot easier. And that's something that we're absolutely looking at and we would really like to do. As far as Lightwave Core is concerned, so I'm really kind of interested in Lightwave Core. Maya's a little, Maya is great. But Maya is a little, it's got some kind of weird idiosyncrasies, and, it clearly is something that was written a long time ago. And, it was built upon from there. And, it's really an excellent pipeline tool, and the reason why it's been so dominant is because there's really nothing else. I mean, that's not entirely true, of course. It's not like you can't use, you can't use 3D Studio Max, or you can't use XSI in production. Of course you can, and lots of people have. But, Maya has a lot of openness to Python, to pipeline tool building in a way that makes it very attractive for those sorts of things. Lightwave Core, because it's node-based and very much based around Python, and looks very configurable. It's starting to look like something where it's like, oh, maybe Maya has a real challenger now. I haven't tried, I haven't tested it, I haven't really seen anything about it that I haven't really had a chance to take a close look at it. But it's certainly something I'm interested in, and it's certainly something where, if it comes out and it looks like it works really well, and it looks like it's something where we can port some of this stuff to it reasonably easily, absolutely it's something that I'd be interested in. And one of the main reasons why we haven't done a setup machine for any other packages is because they're radically different. If you want to build a rig for Lightwave, or you want to build a rig for XSI, or you want to build a rig for Max, all of their architectures are radically different than Maya's. Maya has this node-based system, and all of the rigging tools sort of relating to TSM sort of built around working within that. And it's not that you can't build a great rig with XSI or Max, but it works completely differently under the hood. And so it's not something where we can really get a one-to-one relationship of how things work. We could build a rig that does the same things. You could build it, with different tools, but there's not an easy one-to-one correlation at all. And so depending on what they do with lightwave core, it might actually be a lot easier to do similar sorts of things. And so, yeah, it's something I'm interested in. Will TSM3 and TFM2 require plugins? Will those plugins have free player versions similar to now? The answer is TSM3 will not require a plugin. Although it will have some features where you will need the plugin, but you can make rigs with it that won't need the plugin. TFM2, just like TFM1, will need a plugin, and you will be able to have it for free. We don't really want to put animators in a situation where, in order to use the tools, in order to animate with rigs made with our tools, they'd have to buy a whole plugin. We believe that in the long run, we're going to see basically better growth of the product by making it available to as many people as possible. And that anything that makes it more difficult for somebody to just be like, oh, this looks interesting, I bet I can rig with this, and then send it out to somebody else who doesn't necessarily even know what it is. Anything that makes that easier is going to be good for us. So even though, obviously there would be certain obvious advantages to charging for the plugin, I mean, people would have to pay for it. Is there a mesh density limit for TSM2? There isn't a mesh density limit. If you have a really dense mesh, it'll be really slow, as much as it would be for any other rig. But there's no mesh limit any more than there would be for any other rig that you would do in Maya. I mean, of course, you make your mesh too dense, your rig becomes very slow. I suppose it's possible to make one so dense that it barely runs at all. So I wanted to, at the very end, take a moment. We sort of touched a little bit on what TSM3 is going to be doing, and a little bit on what TFM2 is going to be doing. And I did want to talk a little bit about Anzovin rig tools, if you guys are okay with sticking around for that. And what is it exactly that Anzovin rig tools like? What makes it different from all these other tools? And I sort of mentioned the fact that it's not an auto rig tool; it's a new set of rig nodes, basically. And what those rig nodes are a new set of bones, a new IK handle, a new deformer, and they work differently than Maya's existing bones, IK handles, and deformers. The bones, in particular, do a certain set of things that Maya's bones don't do, which is that they're all B-splines. They're actually not. They're not rigid influences. They're all meant to be bent. They are all meant to be twisted and wrangled in a multitude of ways, and and you can do that very much on the fly while you're animating. You can add bone CVs, in the middle of the bone while you're animating. Each of these bones is a spline curve, and you have a lot of freedom with what you want to do with them. All that stuff I was showing you with manipulating, the TSM spine. Where you could scale one end of it and sort of put a bend in the middle of it, and you could reshape it fairly easily. So all of that stuff is so imagine every single bone you made. You didn't have to do anything special. You didn't have to do anything extra. Every single bone you ever made had all of that ability to do all of those things that a TSM spine does by default. You don't have to use it. We're planning to write it fairly efficiently so that it won't take that into account if you don't actually use those tools. You're free to leave it alone and just use it as a standard bone. But if in the middle of something you decide, wow, it'd be great if I could, modify the arm in this really specific way, you can start using those tools, and it's there for free. You didn't have to add any extra rigging to do it. If you are working with, and similarly, the deformer is going to work in a way quite different from the bone deformation that you may be familiar with. Now it's going to allow for the same sort of things that a skin cluster allows for now. So you can do linear blend weighting, and you can paint between linear blend weights, and maybe dual quaternion as well. But that's really not its primary purpose, because what the deformer will let you do is to treat a joint chain as a single influence. So you're looking at a whole chain of joints. So you're starting at the at the shoulder, and you go all the way through the arm, all the way down to the wrist. It's a single chain of joints. That's a single influence. And because each of those joints is a curve, it's actually treating that whole chain of joints as a single curve. And there is a method that we can't really talk about yet, that we have developed to basically do very nice deformation off of that curve. So it's not like a sort of wire deformer, right? So that's the most analogous thing, is a wire deformer. except this allows you to organize it into a hierarchy and treat it as bones as well. But it's not like a wire deformer. So if you've ever done deformation with wire deformers, they have two issues. I mean, one is that they don't twist. There's no real up vector to a wire deformer, right? And the other issue is that they don't, if you bend one acutely, which is presumably what you'd have, in the middle of a joint, in the middle of an elbow, if you bend one acutely, you'll get all kinds of crimping, and, it doesn't really look good, and, it's not very controllable, so people tend to use, bones, and they can paint weights and stuff. But imagine that you get decent deformation for free, literally for free. You're bending your arm, your deformation is always going to look pretty good. Sort of automatically. Now imagine you can go into that elbow and you could break it down and, treat it like standard weighting if you want to, but alternatively, you can paint the sharpness of the bend in the joint. You can go into that elbow and you have painting tools, but you can paint the sharpness of the elbow. So instead of saying, oh, more to this influence and that influence and the exact way that you paint between the influences, I mean, that's all kind of oblique. That's all kind of, maybe oblique's not the right word. It's kind of obfuscated, right? It's a little hard to visualize. And of course, people who've done rigging for a long time get very good at visualizing what that all means. And the weight painting interface is pretty real time, so you can play around with it. But it's still a sort of strange way to think about deformation versus, oh, I just want it to be sharper right here, And then so you are painting in a more standard way to blend between your bone chain influences. So each chain being an influence, you are blending between those, and you have a something fell off my desk. Whatever. We have a and those are sort of done through Maya's weight painting interface, but you have many fewer to paint. So imagine instead of painting a whole bunch of influences, and to do everything that TSM2 does. I mean, there's a hell of a lot of influences in there. I haven't actually counted them lately, but going through that influence list is kind of a pain. Imagine your arm is a single influence, your spine is a single influence, your head is a single influence, each finger is a single influence, and how much easier that would be to deal with. And that's one of the ways that it treats. You can also break that down if you want to have more influences. You can add standard influences that aren't those bones and do whatever you want. But you have that possibility of essentially just treating things in a very easy way. What are some of the other primary features we're talking about? So here I'm getting into things that are slightly speculative. We've tested them out a little bit, but we haven't tested them well enough to know if they'll get into the first version. So if I was Autodesk, I wouldn't be able to talk to you about this, but Anzovin Studio is not a publicly owned company, so I'm allowed to tell you anything I want, as long as I add the statement that we're not guaranteeing any specific features in the final product beyond the ones I've already told you about. These are all things that we're looking at doing, but we can't guarantee them because the product isn't at a state where we can know how well they'll work yet. But we have high hopes for them. One of those things is being able to have to treat bones, because all of these bones are curves, as essentially, I'm trying to think of a good way to describe this. Think of each of these bones as being able to have a animated bind pose that is actually a reference to another bone. So the best way to think about this, that's sort of the way people deal with Maya now, is think about a lattice. You put down a lattice and you have two objects. You've got the lattice itself, and then you have that little cube thing that the lattice references for its base position. And there's a lot of things you can do in rigging by deciding that those things move together or they move apart depending on certain things, and you can use them to make relative deformations. Well, you can do that, and I mean there's a lot of things. You can do that with clusters too. You can do that with wire deformers. You can't do that with bones in Maya as it currently exists, or at least, I mean, you can create the same effect, but not in a very easy way. So you're getting all of these bones that can be curved in any way you want, and they can have just a standard bind pose where it's like, well, they're bound in this specific position. Or you can put down another bone and say, oh, it's reference to that bone, that other bone is its bind pose. And that allows for, and it's a little hard to explain that without sort of showing some examples, which I can't show you right now, but that allows for all kinds of interesting rigging effects that are very easy to create that would be quite difficult to create under any other circumstances, or at least a lot of work, you know. Um, so some of the other things, and one of the other things we hope to see a lot from it is speed. So you're seeing the speed of a TSM2 rig. It's okay. And we think we can make it a little better in TSM3. Um, but you get 10 TSM characters in there, and your scene is going to crawl. There's just no way around it. Um, and the rig's fairly complex. It's got a lot of features, and it's has a lot of stuff going on. And what we realized was, the next step, I mean, is to take a whole bunch of those features and just sort of combine them into a single node. Just a simple example, the IK handle that we wrote for Anzovin Rig Tools has all of that stretchy stuff that I was just showing you built into the IK handle. You don't need to do anything to create that. It comes with every IK handle. You can turn it off, of course, but it's there in every single IK handle. You put down, if you ever decide you need it, it's a checkbox away. Similarly, getting twist propagation down an arm. And one of the other nice things about treating each bone as a B-spline is that we also have spline interpolation of the twist around that B-spline. So we literally have a slider that lets you set, the twist happens right in here, or you can just extend the twist out as far as you want. And instead of having something where you're thinking a lot about influences, or you're thinking about the specific way that a bunch of influences have to interact to create that effect, you have a simple slider that you can say, I push the twist out 50% of the way, or 90% of the way, or 100% of the way, or whatever you want. And internally, that thing that I just showed you about aim without up vector, and being able to aim stably without an up vector, this is all integrated into all of Anzovin Rig tools at the base level. So anytime you're twisting anything, you will always get a stable twist. You will never get a pop. It will never happen. Well, except for one situation. I mean, if you twist it past 180 degrees, it'll pop around to the other way around, because quaternion math will try to find the shortest path for the twist. So you can get a pop in that specific situation, although we are trying to figure out tools that'll allow you to get out of that problem as well. But you won't get pops because you're going past a pole vector. And even internally within the system, you won't get that. And so everything will just operate together in a much smoother fashion. And these are all nodes. I mean, they're bones, and they're IK handles, and they're stuff. You can write your own auto rig tools to use these bones if you want. They're fully accessible. They're their own nodes. You can call them through Python. You can call them through Mel. You can do whatever you want with them. And therefore, they'll fit in a production pipeline in a way that a tool like TSM. I mean, you can certainly fit it into a production pipeline, but it's not something where you're going to be able to change it, and you are going to be able to change this. You are going to be able to use it within your own tools. And that's something that I think will make it much more attractive to people in studios who probably wouldn't want a black box solution like TSM. Let's see, what are the other sort of things? We're going looking at building a much better. So Anzovin Rig Tools bones don't work like Maya bones do. So Maya bones, well, there isn't really any such thing as a Maya bone. There are joints, and then there's this notional idea of bones that are kind of stretched between the joints. And it's very notional. It's very those things don't have any real existence in the scene. They're just a part of the way bones draw, and that can be a little confusing. Like trying to and people who do a lot of rigging, of course, get pretty good at knowing how this is supposed to work. But you put down a lot of joints, and unless you're paying a lot of attention, you can easily have their rotate, their spaces pointing in all kinds of different directions, and their axes all misaligned, and all kinds of stuff that you wouldn't expect, and there's no immediate visual indication of that. And we're trying to write bones that are the bone has an actual existence in the scene. So the hierarchy doesn't go joint, 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 joint. It goes joint, bone, joint, bone, joint, bone. Bones are actual objects. They have a length, and this allows you to work with the bones in a way that is, I mean, the bones themselves have an actual existence in the scene, which is where you get your ability to manipulate the bones and add CVs to them and treat them like B-splines. And the I mean, you can think of the bone almost as being the joint's shape node in a way, although the hierarchy doesn't work quite exactly like that. Um, but they're going to draw. We're working on having them draw in a way that makes it much more apparent what's actually going on in the rig, and much more apparent where all of the axes are pointing, and much more apparent, um, when things are misaligned, and also making tools to manipulate those joints where you can sort of go in there and move them around pretty easily, and the axes will do something reasonable. They won't necessarily do exactly what you want. I mean, you can certainly go in and edit them in any way you want, but they'll do something that is not crazy. And this also comes with aim without up vector, actually, because and it's amazing how much we're using that relatively simple tool and relatively simple math, but um, because without the ability to aim consistently in any direction without, or almost any direction without incurring flip problems, you don't really have an ability to be arbitrary about where you place your joints and still get something reasonable for their axes. And so we're working on basically just trying to make the experience of working with rigging in Maya and working with bones in Maya and working with IK handles in Maya much more intuitive, much simpler, much more something where you get a lot of what you're going to need every day, there to be turned on with a checkbox instead of built from a whole bunch of rigging nodes. And I mean, all of the stuff with the way shoulders work. I mean, the system in TSM for dealing with shoulders is pretty complex, and the system in most rigs I've seen that deal with it well are pretty complex. I mean, they're not crazy, but you know why? But that's something you need in almost any rig. I mean, there's hardly any situation in which you fundamentally don't need good shoulder twist propagation, right? I mean, there are certainly not many. There are, but they're pretty rare. Like most characters need that. So why is that something that needs to be rebuilt and that is complex, every time? And we're trying to build something that hopefully is gonna really push rigging further and make dealing with rigs, even without an auto rigger, something that is much more pleasant to deal with, and hopefully also give pro users, people who are rigging professionals, a new set of tools in their toolbox that they can mix in with their existing tools and use where it suits them, and be very useful to them in a way that will really make certain tasks much easier, and that's pretty much what we're going for. So I gave you my little spiel about Anzovin Rig Tools is hoped for future awesomeness, and we really have very high hopes for how well that will go. But anyway, yes, I think it's about time to wrap things up. Thank you all very much for coming to this talk, and I hope you all enjoyed it.